and imagine yourself roughly 200,000 years ago. You're not a king, you're not a farmer, and you certainly aren't a philosopher. You are just a regular Homo sapiens standing somewhere in East Africa, probably wondering where your next meal is coming from, and really hoping nothing with larger teeth finds you first. If you could somehow snap a selfie right then and compare it to the billions of people alive today, one thing would immediately jump out at you. You probably wouldn't be white. You probably wouldn't be Asian. The very first modern humans almost certainly had dark skin. So, here's the big question. If humanity started out with dark skin, where on earth did all the other colors come from? How did we go from a single, shared baseline color to populations ranging from extremely dark to extremely light, in literally every imaginable shade in between? Why did some groups develop lighter skin while others stayed dark, or even evolved completely different genetic solutions to the exact same environmental problem? What we are actually looking at here is one of the strangest, most fascinating examples of evolution happening right in plain sight. To figure this out, we're going to trace our evolutionary journey through 6 parts. 1. The original human color. 2. Nature's ultimate sunscreen. 3. The Great Migration Problem. 4. Evolving different solutions. 5. The colorful human spectrum. And finally, 6. The race illusion. All right, let's kick things off with part 1, the original human color. Get this, for almost 90% of Homo sapiens history, everyone lived in Africa. And as you might guess, Africa gets a lot of sunlight, an almost ridiculous amount actually. Now, today we tend to think of sunlight as that pleasant, warm feeling you get on a tropical vacation, but constant daily exposure to that level of radiation over thousands of generations, that can quietly destroy your DNA. Which brings us to section 2, nature's ultimate sunscreen. Enter melanin. It's the pigment that gives skin its darker color. But way more importantly, it acts as nature's built-in sunscreen. Melanin actively absorbs harmful ultraviolet radiation before that radiation can damage your cells, destroy your body's essential folate levels, and basically create a biological disaster. Having lots of melanin in equatorial Africa wasn't just some nice cosmetic feature. It was a massive evolutionary advantage. It protected generation after generation from a brutally harsh environment. Because, let's be honest, evolution does not care about appearances. It only cares about one thing. It has one single performance review. Did you survive long enough to have kids? That's it. That's the whole shebang. And for hundreds of thousands of years, in that high UV environment, dark skin was quite simply humanity's greatest biological asset. Over enough time, it just became the absolute norm. But then, things changed. Section 3, the Great Migration Problem. So picture this, about 60 to 80,000 years ago, groups of humans started packing up and walking out of Africa. They pushed into the Middle East, Europe, Asia, and eventually all the way to the Americas. And they did all of this, by the way, without smartphones recalculating their routes. But as these populations spread farther and farther north, the environment shifted dramatically. The intense beating sunlight of the equator faded away, and the ultraviolet radiation became much, much weaker. This created an entirely new, unexpected environmental challenge. Now, you might be thinking, hey, less UV radiation sounds fantastic. No more sunburns, right? Well, that was great until humans realized a critical flaw in their new setup. Your body actually needs a certain amount of that damaging sunlight to produce vitamin D, and vitamin D is incredibly important. Without enough of it, your bones weaken, your immune system suffers, and childhood development becomes incredibly difficult. Suddenly, the very trait that kept humans alive in Africa was becoming a serious liability up north. So, how did our bodies fix this? Section 4. Evolving different solutions. The dark skin that blocked UV radiation so effectively was now coming with a heavy cost, and natural selection slowly began favoring individuals with lighter skin who could absorb more of that weak sunlight. You probably intuitively assume that modern-looking pale Europeans popped up the very second humans crossed into the continent, right? Well, ancient DNA tells a totally different, totally fascinating story. The first humans in Europe were actually still fairly dark-skinned. In fact, DNA reveals that hunter-gatherers living in Europe thousands of years ago had dark-skinned paired with blue eyes. It's almost like evolution accidentally randomized a character creator screen. The pale skin we associate with Europe today didn't actually become widespread until much, much later. As farming spread, human diets changed, and new genetic mutations took hold to maximize vitamin D production. And it actually gets even stranger. Europe and East Asia both encountered very similar environmental pressures, meaning low sunlight. But they independently developed their own, totally distinct genetic solutions to achieve lighter skin. They arrived at similar evolutionary outcomes, but they took completely separate genetic pathways to get there. Evolution wasn't just following a single blueprint. I love this analogy. It's exactly like two students taking the same math test. Both of them get the correct answer at the end, but they use completely different formulas to get there. Human populations found different ways to adapt to low sunlight environments. The destination was similar, but the evolutionary road was entirely different. It's almost like nature is just showing off how creative it can be. Moving right along to section 5, the colorful human spectrum. So what about everyone living in between these extreme geographic zones of the equator and the far north? Well, this part of the evolutionary journey completely blows up the way we usually talk about race. People tend to imagine human skin color in three simple, easy-to-remember categories: black, white, and Asian. But biologically speaking, that is just completely wrong. As humans spread across the planet, local environments, some with intense UV, some moderate, some highly seasonal, created wildly varying selective pressures. Add in the fact that human populations were constantly moving and mixing repeatedly over thousands of years, and the result wasn't three neat colors. It was hundreds, maybe thousands of unique, localized pigmentation patterns.
Yeah, humanity definitely didn't divide itself into a few neat little boxes. Indigenous Australians, North Africans, South Asians, Middle Easterners, and Native Americans all followed their own specific evolutionary paths. Skin color is actually an endless, messy continuum stretching across all the continents. It diversified continuously and beautifully, which is exactly the way evolution tends to handle pretty much everything.
Which brings us to our final part, Section 6, the race illusion. For the vast majority of our species' existence, around 200,000 years, humanity spent its time looking relatively similar. The visible differences we obsess over so much today represent just a tiny, tiny fraction of our history. A few thousand generations. That is literally a blink of an eye in evolutionary terms. Underneath all those superficial differences in our skin, we remain remarkably, undeniably similar on a genetic level. Because at the end of the day, there's just one species, one shared origin, one African beginning. If you go back far enough, the darkest skin, the lightest skin, the blonde Scandinavian, the Korean engineer, the Peruvian farmer, every single one of their family trees eventually merges. The incredible thing about human pigmentation isn't that we're so different from each other, it's that we are different in such predictable, logical ways, simply because the exact same species encountered different worlds and survived them together.
Every single shade on Earth today is just part of that exact same journey, responding predictably to a little more or a little less sunlight over thousands of years. The story for all of us starts in the exact same place. So here's a question to take away with you today. The next time you look in the mirror, ask yourself, what variation of this ancient, brilliant biological experience